Good morning. Am I audible? So we start the day. We write a program for finding sum of first n natural numbers. Formula we know, n into n plus 1 by 2. So if we write that without recursion, yes. So sum n sum if sum equal to n into n plus 1 by 2. Again, the name of the variable and name of the predicate, both the things are same. It is sum. So my in the goal section we'll have something like sum, then 3, and then answer our x. And we want x equal to 3 into 4 divided by 2. So if we don't use recursion, then the simple mathematical formula is variable sum is equal to n into n plus 1 by 2. We'll get the appropriate answer. But then we want to write, actually we want to write a recursive definition, not the way we have written, not like n into n plus 1 by 2. So we go to the recursive definition, and here is the recursive definition. Sum of zero number, first zero number is 0, that is the terminating condition, and sum of n is sum. Here we are putting the condition. Yesterday we said that in an example, the previous example, if this nth element, if n is inappropriate, then we can put a condition. Here is an example where if n is inappropriate, we are putting a condition, n greater than 0. Exactly in the same way, we can put a condition in the case of nth element to validate n. N cannot be negative. So here we are putting that n is greater than 0, and n1 equal to n minus 1, we are using a new variable. Please note that as discussed yesterday, we can't write n equal to n minus 1 in prolog. That will always return false. N equal to n minus 1 will always return false. So it will make close false. Don't put any such condition. We are validating n greater than 0. We are using one more variable n1, and we are decrementing the counter n1 equal to n minus 1. And if sum of n1 is r1, if sum of n1, so we are not considering the last element, it is all the elements except the last one, n1 equal to n minus 1. So if sum of n1 is r1, then my final sum, that is second argument in the predicate sum, s is small in this, that's the predicate sum having two arguments, one is n, capital N, second is capital sum. The second argument is a variable. So if sum of n1 terms is r1, then my total sum we know it is r1 plus the term that we have ignored. The term that we have ignored is n. So if sum of n1 is containing all the terms except the nth term, n1 equal to n minus 1. So if sum of n1 is r1, then my final sum is r1 plus n. That completes the recursive definition. Sum of n1 is r1, then my final sum, which is my second argument, that is what I am looking for, that equals r1 plus n. And because this is a recursive call, sum of n1 is r1, n1 equal to n minus 1, every time we'll decrement a count, and ultimately this n1 will become 0. That will become 0. So sum of 0 is 0. We'll get that r1 will be equal to 0, and while unwinding the recursion, the last goal, sum equal to r1 plus n, will be added. So that is how we obtain sum of first n natural number. And as stated earlier, without recursion, without recursion, we could have written that using the directly using the formula, we could have written that. This one, sum of first n natural number is sum, where sum is equal to n into n plus 1 by 2. But we are not here showing the mathematical use of Prolog. To be a good Prolog programmer, we have to be very good at recursion. So most of valid and meaningful Prolog programs are based on recursion. So next, so we with that we complete this sum of first n natural numbers. Now next we move to finding sum of odd and even elements separately. That's a program for finding odd and not sum, program for finding odd and even elements separately in a list. So I have given an input list. I have to split that list into two parts, one containing only even elements and the second has only odd elements. The problem statement is what? Finding odd and even elements separately and framing lists. That is, split the input list into two lists, one containing odd elements and the other containing only even elements. Input list, I have to split into two separate lists, one having only odd elements and the second having only even elements. This is second program of the day. This is second program of the day. So here is the statement more. Yeah, this is the program. Finding odd and even elements separately and framing list. That is, split the input list into two lists, one containing odd elements and other has only even elements. So if my list is say 5 3 5 comma 3 comma 2 comma 1, my name of the predicate is OE, odd even, OE. My first argument is 5 comma 3 comma 2 comma 1, that is my input list, and it has two more arguments which are x and y. In the goal section, what I am writing, OE, that is odd even. There are three arguments. They are list comma list comma list. The first argument is a list, which is my input list. Second argument stores all the odd elements without changing the sequence of elements in the list. In the third argument, once again a variable like second argument, and it stores only even elements. So in the goal section, I'll write something like OE within list notation 5 comma 3 comma 2 comma 1. That is my input list. Second argument capital X. Third argument capital Y. So X, the second argument, will store a list having only odd elements. So X equal to list 5 comma 3 comma 1, because in my input list the odd elements are 5 3 1. Even element, only even element present is 2. So Y is equal to list 2, one solution. That is the required output. You are seeing that my goal is OE 5 3 2 1, 5 comma 3 comma 2 comma 1. Second is capital X, third is capital Y. So X is equal to 5 3 1, that is visible. Y is equal to 2, one solution, this is required. The second argument stores all, it frames a list containing all the odd elements. And the third argument, it stores all the even elements in a list notation. So my OE, it is list comma list comma list. Try to define this. Try to define this. Try to define this OE. I hope the requirement is clear. The problem statement is clear. Is the problem statement clear? No response. Is the problem statement clear? Okay. Okay, fine, fine. Okay, fine. Ashutosh, good. Atish, Chintal, Gata, fine. So try to write this OE. Please note that there is a MOD operator. So we can use the mode operator of Prolog, MOD. So I'll split my list. My first argument I am processing because that is my input list. And I will appropriately, I'll process the elements of the first list one by one. So head and tail. And I'll check that head. In every iteration, I'll check the head. And very simple, I'll apply the mode operator. And we'll see that whether that is an even number or an odd number, and accordingly I'll add either to the second argument or to the third argument. I split my first list into head and tail. So in every iteration I'll check the head and ensure whether that is odd number, or I'll verify whether that is an odd number or an even number. Accordingly, I'll add that to variable x or variable y. X has only odd numbers, y is a list containing only even numbers. So it is something like OE, my odd even. My first argument will be h bar t, ht. Within list notation, that is ht. I'm not telling the second and the third argument. My first argument is h vertical bar t. That is my first argument because I process one element at a time from the input list. So I divide my first argument into head and tail. Second argument I don't tell. Third argument I am not telling. If, that is colon hyphen, my first sub goal is h mod 2, h mod 2 not equal to 0. Again, less than, greater than, that is a symbol for not equal to in Prolog. H mod is an operator having the same meaning as mod. H mod 2 not equal to 0. So that is an odd element. H mod 2 not equal to 0. It means there is a remainder. It means it is an odd element. So I have to add this odd element appropriately. I am ultimately framing my second list and the third list. Second list, that is x, third list, that was y. So I have to find out elements in x, I have to define elements in y. So OE, my first argument is h bar t. Second argument I have to appropriately frame. Third argument, we have to write that properly. If h mod 2 not equal to 0, comma, again a recursive call, the tail recursive call, it is OE, and again you write down the elements. So tell me the second argument, third argument of OE, and tell me in that recursive call at the end what I have to write as OE. My current clause is OE, h bar t, that is my first argument. You have to find out the second argument and the third argument. If h mod 2 not equal to 0 is my condition number 1, and that is comma, it is OE, the second call is OE, and again you have to decide the arguments of this OE. What should be the argument of this OE? So write down arguments of OE, the second and the third argument. First I have already mentioned. In the conclusion part, and write out the argument of OE in the condition part. This is a tail recursive call, so that OE is called as a last call. Once again, OE is called as the last call. If anyone can write down arguments of OE in conclusion and arguments of OE in condition. My first condition is h mod 2 not equal to 0. My second condition is OE, and then you mention those arguments. Again, in the goal section, it is OE, my list like 5, 3, 2, 1, comma X, the second argument, comma Y, the third argument. Expected answer is X equal to list 5, 3, 1, Y equal to list 2, 1 solution. So X contains all odd elements, Y contains all even elements, and there is no change in the sequence of elements from the original list. The sequence of elements of the original list is maintained. That is the requirement. Atish is writing, no, if else, there is no such if else. There is no if else in prologue. Append as such not required to use. Append not required to use. No need to use append. I mean, we are appending, but there is no need to explicitly write append predicate. Of course, we'll append. Let me tell you, let the terminating conditions be. Let the terminating condition be OE, empty list, empty list, empty list. My terminating condition is OE, parenthesis, empty list, comma, empty list, comma, empty list. That is the terminating condition. The terminating condition is OE and all three empty lists. So I repeat clause number 2 and I repeat clause number 3. I hope you understand that there are three clauses. The first clause, that is corresponding to the terminating condition. Second clause, it is when H, the first element from the current list, that is odd. The third condition, it is when H is even. So there are three clauses. Clause number 1 is OE, empty list, empty list, empty list. That is my clause number 1. My in clause number 2, see, given the terminating condition is OE, empty list, empty list, empty list, it means my initial value of X, the list of odd integers, that initial value is empty list. Similarly, initial value of the list of even integers is also an empty list. So I'll be adding elements to that empty lists, the second and the third arguments, depending upon whether head is odd or even. So I'll be appending this H to the second argument. If it is odd, I'll be framing the second argument. If it is even, I'll be framing the third argument. Moreover, I don't want to change the sequence of elements in the original list. I don't want to change the sequence of elements in the original list. Try to recollect the definition of append. Append empty list L, comma L, the terminating condition. Append X L1, L2, X L3 if append L1, L2, L3. I'll repeat the second clause there. Append X bar L1, comma X2, comma X bar L3 if append L1, L2, L3. And the terminating condition is there. Append empty list, comma L, comma L. See, in the second clause in the definition of append, let me go to that if I get that. Let me try to go there. The second clause is append x bar L1, L2, x bar L3 if append L1, L2, L3. Here the requirement is I don't want to change the sequence of elements. I don't want to change the sequence of elements in the appended list. So if it is append AB, comma CD, comma X, I want answer to be ABCD. And what I'm doing, I am detaching elements of the first list and then putting that appropriately in the conclusion part itself. And if you look at the execution trace, then this x's will be added while unwinding the recursion in the reverse order. If you look at the execution trace, then these x's are getting appended while unwinding the recursion. So if I don't want to, if you look at this execution trace, then I am my final answer, that is the third argument. And this x's that we have removed, for example, you look at the second last line, return append b c comma d b c d, the second last line of your screen. This b is getting appended to cd in the reverse direction. So b was detached after a, so b was last to be detached from the original list, but then it is getting appended first to cd. It is first getting appended, and then we get a appended once the list bcd is formed. Once the list bcd is formed, then a is getting appended. Once the list bcd is formed, then a is getting appended, and a was the first element to be detached, so it is actually in the LIFO order. I mean, the element that is detached last gets attached first. How is that ensured? Because this is getting attached while unwinding the recursion. How is that ensured? By defining append the way we had defined, by putting these detached elements in the conclusion part to this L3. L3 is formed afterwards at the terminating time. When the original list is empty, whatever is the content of the second list is the content of the third list. So if it is append AB, A comma B, C comma D, then my initial value of the third argument is C comma D. When the first list is empty, whatever is the content of the second argument, that is C comma D, that is my initial answer, that is this C comma D, and that is the value of actually L3. Going to the second clause, that is L3, and to that L3 we are attaching this X that we have removed from the first argument. So that is done in the reverse order. So if my first list is A comma B, then I'll attach, while following this in the reverse direction, I'll attach B first, then A, by writing this X bar L3. By writing like X bar L3, we are maintaining the sequence of the elements in the final answer, and this attachment of the elements of the first list, that is done in the reverse order. If it is A comma B, then to CD will attach B first and then A, and that we have already seen in the execution trace. Once again, going there. So this is the first time I am getting the value of CD. I am at line number 3 of your screen. Append empty list C comma D, C comma D. That is the third line. This is the first time I am getting value of L3. And then to that L3, we are attaching the elements of the first list. My first list in the current example is A comma B. So we are attaching to this CD the third argument in the reverse order. It was A comma B, so we will attach B first, then A. So this becomes BCD, and then this becomes ABCD. How is that ensured? By writing the third argument as X bar L3, that already we have seen. By writing third argument as X bar L3. By writing the third argument as X bar L3, we are maintaining the sequence of elements of the original list. So it ABCD, it remains AB comma CD. My answer is ABCD. The sequence is maintained. Now we go to our OD1. Now we move to our OD1. This is the final definition of OD1. Now have a look at that. I think Malia has rightly written that when the condition is when it is an odd element. So the second clause, the condition is h mod 2 not equal to 0, means h is odd. I'm attaching that to the second argument. My second argument is a list containing all only odd elements. And in case that's the third clause, the third clause, the third clause. If it is h mod 2 equal to 0, then I'm adding that to the third argument. My condition there is h mod 2 equal to 0. The second condition is OE T T1 T2, no change in that. The last clause, the last line of your screen, it is this if h mod 2 equal to 0, comma OE T T1 T2. So I am maintaining sequence of the second element, the second argument, using clause number 2. I am adding that to T1 if it is odd, and also maintaining the sequence by appending this H in the conclusion part. Similarly, I am appropriately including this for the variable y, the third argument, if it is even, and also maintaining the sequence by writing like h bar T2. The initial value of x, the second argument, that is empty list. Initial value of y, the third argument, that is also empty list. We go on processing all the elements of the input list till it gets empty. Therefore, the first argument, the terminating condition there, it is empty list. OE, empty list, empty list, empty list. I process, I am at clause number 2. I process the first argument, my input list split as head and tail. In case h mod 2 is not equal to 0, it means h, there is a remainder, not equal to 0, there is a remainder. It means h, that is an odd element. Therefore, I append to T1. Initial of value of T1 is empty list, and this h will get added while unwinding the recursion in the reverse order. That will ensure that the sequence of elements that is maintained. In the answer, I get 5, 3, 1, not any other order. So I'm at clause number 2, h mod 2 not equal to 0, and then again I call OD1 with the reduced list. I have already processed h in the input list. I have already processed h. Now I have to process remaining elements, that is t, and I am searching for value of T1 and T2 so that I can appropriately find value for x and y. So there is an invocation of OE, the tail recursive call, OE T comma T1 comma T2. T is my reduced list, H I have already processed, and depending upon that I have added to either T1 or T2, either T1 or left it alone so that I can add to T2 in the next clause. And then again I am calling OE T T1 T2. So that will generate the list X and Y without changing the sequence. So rule of thumb is by writing this splitted element H in the conclusion part, the order of elements does not change. The heuristic, the rule of thumb, by writing the splitted element in the conclusion part, the order of elements of list does not change. Definition is over. Is that clear to all? Just check it out. Is that understood by all? Janik, yes. Priyal, yes. Chintal, yes. Fine. Gata, yes. Atish, yes. Malia, yes. Fine. So this was, anyone has any doubt? Anyone has not followed this? Seems okay. Now let us go to the reverse. In the previous lecture, we had defined the predicate reverse with 3 arguments. Something like reverse 1, 2, 3, empty list, x, and then answer we were getting is x equal to 3, 2, 1. 3, 2, 1. So reverse we had defined using accumulating parameter. The additional second parameter, the empty list, we were giving as an input. Reverse, first list is 1 comma 2 comma 3, second list the empty list, the third list say capital X, where for in which I have to store the reversed list. So X will be something like list 3 comma 2 comma 1, one solution. So second argument was the empty list, that is called accumulating parameter. That's the additional parameter that we are giving as a part of input. Now here is the second version of reverse without accumulating parameter, with only two arguments, with only two arguments. So if my goal is reverse 1 2 3 comma r, then required output is 3 comma 2 comma 1. We are not giving any accumulating parameter. Also in the definition we are keeping two arguments. Otherwise without accumulating parameter, still I can add that empty list while writing that clause and add a parameter. Even in the definition I want to have only two arguments, not only in the goal but in the definition, in the clause also. In the clauses also I want two parameters for reverse. So that's the requirement. How can we define that? Try to think about the logic. How can we define reverse using only two parameters? Two parameters in the goal, two parameters in the definition. Reverse, it is h bar t comma z. Try to define this. Reverse, I'm writing clause number 2. I'm stating part of clause number 2. Reverse, my first argument is h bar t, h vertical bar t, ht, comma z. If, now what can be the conditions of if? Reverse ht comma z, z is the second argument that will store the value 3 comma 2 comma 1 for our given example. Reverse h bar t comma z if a clue is, you can use append here. You can use append here. Defining reverse using two arguments only. And a big clue is this can be easily defined in terms of append predicate. So if my input is 1 comma 2 comma 3, then if I discard head for time being and focus on the tail, it is 2 comma 3. And if I reverse the tail, if I reverse the elements of the tail, my input is 1 comma 2 comma 3, head is 1. Right now I am not looking into that. My tail list contains the elements 2 comma 3, and if I reverse this tail, then it will become 3 comma 2. To that, if I put head is 1, then it becomes 3 comma 2 comma 1, and that is my answer. In fact, I have already defined this. I have written the definition. I have completed the definition. My goal, my input is 1 comma 2 comma 3, head is 1, tail list 2 comma 3. So if I process the elements of the tail and I see that elements in the reverse order, that 2 comma 3 becomes 3 comma 2. If I reverse the elements of the tail, then 2 3 becomes 3 comma 2. And to that, if I put 1 at the end, then that becomes 3 comma 2 comma 1, and that is what exactly we need. That is the required output, 3 2 1. In fact, I have already defined this. What is that? Reverse ht comma z. If anyone wishes to write whatever I have said, I have already said the logic. Reverse of t is x and append x. Malia, you have to complete this append properly. Append has 3 arguments. Don't write z equal to append xh. Remove z equal to and appropriately complete append. Append has 3 arguments. Append xhz. Jainik now rightly said. Now rightly said. Malia, you have to put h in bracket because h is a basic value and append requires all the 3 lists. So it is x comma bracket h, list h, is rightly written by Jainik. Yeah. So that is what will be the terminating condition? What will be the terminating condition? Rightly said. Jamin rightly said reverse empty list, empty list. Very simple terminating condition. I'm not, yeah. Reverse. The requirement is reverse 1, 2, 3, comma R, the goal section. R must be 3 to 1, the reverse list. The terminating condition is reverse empty list, empty list. What is the actual definition? Reverse ht comma z. If reverse of t is t1, if reverse of tail is t1, then if I append to t1 the element h, then it generates my answer z, which is the totally reversed list. If reverse of t is t1 and to t1 if I append h, then I generate h, the entire list is reversed. But then this is left recursive call. Every time I'll be invoking this reverse t1. So finally this invocation will stop when the first argument is empty, and that will be the initial value of t1. Reverse of empty list is empty list, and then to that these heads will be appended. To this the heads will be appended in the reverse order. If it is 1, 2, 3, then that will be appended as to generate answer 3 to 1. Here is the execution trace. Yeah. Let me see if it becomes more clear. Yes, this one. So goal is reverse 1, 2, 3. Goal is reverse 1, 2, 3, comma R or Z. R in the goal section, it is same as Z in the clause number 2. So it is invoking reverse. It is invoking reverse t comma t1. T is the tail. So tail of the first list is 2 comma 3. Tail of the first list is 2 comma 3, and second argument is t1. Its value we don't know, that is underscore. Now that will call once again. This does not match the first clause because first clause has all empty list. Call reverse 2, 3, comma underscore, and it does not match the first list because first list, it does not match the first clause because the requirement is first argument to be an empty list. Not the case. So prolog will do backtracking. Go to the next clause. There is one more clause, and therefore it is calling reverse. The second call, it is calling reverse. Once again, it is t comma t1. So tail of this list, it is 3, and this t1 is yet not known. That is yet not known. And once again, some one or two lines are not visible. So below reverse 3 comma underscore, once again it will call. Currently we are, I'm looking at line number 4. Call reverse bracket 3 underscore. Again, this does not match the first clause because the first clause requirement is empty list. My terminating condition is reverse empty list comma empty list. Does not match clause number 1. Therefore, it will try the next clause, clause number 2, which is a rule, and therefore it invokes reverse again t comma t1. So that is t is the tail of this list, tail of list having 3 element. The tail is empty list. So it invokes reverse empty list underscore. My current goal is reverse bracket 3 underscore. We are matching clause number 2. Clause number 2 is a rule. The condition is reverse t comma t1. T is the tail of this original list. So it is invoking reverse empty list underscore. For the first time, my first argument is an empty list. Therefore, it will successfully match, and for the first time, it is executing the return statement. So it is return a reverse empty list empty list. These two statements are not visible as of now. It is return a reverse empty list empty list. Once that is returned, next part is the append statement. Next part is the append statement. I will go upward. For the first time, we are at clause number 2. For the first time, reverse is returning successfully. It is when reverse, this was empty list, t was empty list, and the first value of t1, that is also empty list. So once this is successful, until now, because of left recursive call, we were only between the conclusion and the first sub goal. Reverse invoking reverse, we have never come to the append. Left recursive definition. Only when the reverse succeeds, we can call append. And reverse has succeeded for the first time with the value of t equal to empty list. At that point of time, t1 gets the value empty list. So once this reverse, the last reverse succeeds, before previous reverses are unwinded, there is a execution of append t1 hz. So append t1 has the value empty list. The last t1 has the value empty list. This we obtained because of the terminating condition. Reverse empty list underscore returned reverse empty list empty list. So initial value of t1, that is empty list. Next is call. After that, there is a call append value of t1, that is empty list, value of h. At that point of time, what will be the value of h? When reverse succeeds ultimately, value of t1 is empty list, value of t is empty list. What is the value of h? What is the value of h? We are doing execution trace for reverse 1, 2, 3, r. When finally reverse succeeds with t equal to empty list, t1 gets the value empty list. Next is append, and we require h there. t1 is empty list. What is the value of h at that point of time? The last element. Jenny correctly said the last element, and that last element is 3. That last element is 3. So value of h is 3. It has succeeded when it was reverse bracket 3 underscore, that is the conclusion part, the condition part, reverse empty list underscore returns reverse empty list. At that point of time, my original list has only one element, which is 3, which is the last element. Therefore value of h is equal to 3. Therefore Now append will return. Now append will return. It becomes call append empty list 3, that h value is 3, then underscore, and my underscore value will be 3. So that will be the successful innermost call to the reverse. That will be successful innermost call to the reverse. This one, the third last line, return append empty list 3 comma 3. So this is the first successful return of the entire reverse outside. First call reverse, second call append, which has succeeded. So call append empty list 3 underscore, and as per the definition of append, this will become return append empty list 3 comma 3. So this is successful. This is the value of z actually. This is value of z, because my clause number 2 is reverse htz if reverse t1 comma append t1 hz. So whatever is the second argument of the reverse, that is z, that is exactly used as a third argument of append. It is append t1 hz. So this is the first value of z, 3. That is the first value of. I'll show you that definition once again. Yeah, reverse t comma t1 is successful. For the first time append is successful. For the first time append is successful, and this is z, the third argument. That was return append. This t1 is empty list. See, upper reverse is successful. Reverse, upper reverse, that is reverse. T is empty list, and T1 value generated, that is empty list. So T1 has the value empty list. Next is append. T1 is empty list. H has value 3. So this is empty list 3. T1 is empty list. This is 3. So answer of Z is 3. List 3. So this Z in the conclusion part, that is also 3. We are using same variable name in the conclusion part and the third argument of append. Both of them are same variable. Both of them are Z. So the first value of Z, it is 3. Then unwinding the recursion, will get different values. The third, the first value that we obtained of Z, that is equal to 3. Again, this 3 is written. Now one more return of the append. This reverse is successful. And after reverse, in the condition part, always there is append. So it is append 3 comma 2 Z, and we get value 3 comma 2 3 2. Return reverse 2 3 comma 3 2. Once again, this is the third time append is invoked. Append 3 2 comma 1 underscore, and answer is 3 2 1. That is how we obtain value as 3 2 1. So my first value that I get for Z is 3. Next value which I get is 2, and that 2, the head part is appended after Z. After this value 3. So that becomes 3 2. And to this 3 2, the first H, that was 1, that is appended, that will generate final answer as 3 2 1. That completes the execution trace. Reverse 1 2 3, 3 2 1. That is the return value. I hope the execution is clear. Any doubt to anyone? Moving once again to the definition. Yeah. Reverse of empty list is empty list. Reverse of HTZ. Arya, is this visible now? Arya, is this visible now? Rutvik, still not visible? Okay. Okay, fine. This screen that is not visible already we have discussed that. Let me see if we can go to the next part. This definition of reverse already I have discussed. I was repeating that. So let me go to the next part. If that just check that if that is visible. Palindrome. Is this visible now? Is the screen visible? Okay. Doesn't matter. Okay. Let us not depend upon the screen. Let us take the next example. Writing a prolog program for testing whether the input list is a palindrome or not. Testing whether the input list is a palindrome or not. Write a prolog program for finding out whether the input list is a palindrome or not. Chat window is visible. So think about the program. My first argument is the input list and whether that is a palindrome or not, that we have to decide. Palindrome L, palindrome comma list, sorry, palindrome in bracket list. We have to define predicate named palindrome. And argument to a palindrome, there is a single argument to a palindrome, and that is a list. That is a list. Define the predicate palindrome, that is a list. Define a predicate named palindrome. There is no need of screen. If it is not coming, doesn't matter. I don't know whether this is visible to you or not. Check if this is visible to you. Meanwhile, you define a predicate named palindrome. Define a predicate called palindrome. Palindrome has a single argument. Palindrome has a single argument, which is a list of integer. Define the palindrome predicate. Define the palindrome predicate. Chintal is writing palindrome if reverse of x comma z if x double equal to is not there in prolog. X equal to z we can write. Chintal, we can write x equal to z. We can write x equal to z. Is the screen visible now? Screen visible now? Oh, okay. Screen visible to everyone? Yeah, what the solution that Chintal has given for palindrome is this one. Actually, even compact version is this one. Palindrome L if reverse of L is equal to L. L is a palindrome if reverse of L is equal to L. And already we have defined two argument reverse earlier in the last example. Very simple definition. Palindrome L if reverse L comma L. One more, this is the most compact version. We could have written in another version, may not be very compact. This is the definition of reverse using compare. Same definition of reverse, reverse empty list, reverse HT result if reverse of T is tail1 and append T1H, that will give us result. Same last definition of reverse. Same definition of append. Append blank, append blank LL, append X1 L2 XL3, append L1 L2 L. No change in the definition of reverse, no change in the definition of append. So if we say palindrome race car, answer is yes, that's a palindrome. Palindrome students, not a palindrome. That is our requirement. That's a problem statement. Race car is a palindrome. Students, not a palindrome. ST matches in both the cases, but third character from left is U. The third character from right is N. In the case of students, it's not a palindrome. So no change in the definition of reverse, no change in the definition of append. And here we are defining compare. We are defining compare. Compare empty list, compare HT1 comma HT2 if suppose it is if compare T1 comma T2. So compare we are giving two strings and there's a matching of these strings character by character from the beginning. So compare works like this: compare empty list, compare HT comma, compare HT1 comma HT2 if compare T1 T2, if compare T1 comma T2. So what we are doing, we are taking one character, the head of the first list, head of the second list. In case they match, then we match remaining elements of T1 and T2. We match remaining elements of the string. And this is done repeatedly till both the elements become empty. That's how compare operates. Given that definition of compare, I think now we can write the simple definition of palindrome, palindrome list. Can you, given the definition of reverse, given the definition of append, given the definition of compare, how should I write palindrome? How should I write palindrome list? Here is the definition, palindrome list. If reverse of list, if reverse of list is list 1, so my input list is say 1 comma 2 comma 3, I am reversing that. So that is 1 2 3, and the second list is 3 2 1, and then I am operating the compare. Reverse of list is list 1, reverse of list is list 1, and then I am comparing list and list 1. Then I am comparing list and list 1. And all the elements should match till both the strings are empty. What I'm doing, I'm palindrome list, I am taking reverse of the list, and then I'm matching. I'm matching first element with the last element. So in the case of something like ABBA, I'm reversing that and then matching from the front. It will match only if it is a palindrome. So this is a very simple definition. Of course, the next definition is extremely simple. Palindrome L if reverse L comma L. This is also simple. We are reversing the input list and then matching. We are reversing the input list and then matching. So that is version number 2 in the definition of palindrome. There could be more versions as well. Try to have a look at this. The third version for palindrome. Palindrome version 3 or version 4 for that matter. Palindrome version 3. Palindrome empty list. Palindrome empty list underscore. Palindrome HT. If reverse of T is H bar T1. And then next is we are invoking palindrome T1. Empty list is a palindrome. List containing single element is a palindrome. These are clauses 1 and 2. And my third clause is palindrome HT. If reverse of T is H bar T1 and palindrome T1. So basically what I am doing, I am finding out reverse of my input list. And that answer I am splitting, the reverse list I am splitting as H bar T1. So this H in the first argument in the original list should match. Basically, I'm checking H with the first argument of the original list, and then I am reversing the remaining elements. I am reversing T, I am reversing tail. And in that reverse tail, I must get the first argument as H. One, for example, my original list is say 1 2 2 1. My original list is 1 comma 2 comma 2 comma 1 1 2 2 1. So in my original list, that is my palindrome H bar T. H value is 1. Tail is 2 2 1, and I am reversing tail. So reverse of 2 2 1 is 1 2 2. Reverse of 2 to 1 is 1 2 2. So that in this reverse I must have the first answer as H. So that is reverse T comma H bar T1. 1 2 2 1. My original H is 1, and this 2 to 1 I am reversing that. So that becomes 1 double 2. So this 1, the first argument in the reverse list must be H. It is same as H. So it is H bar T1. If they match, then I have to now reverse the remaining elements. 1 2 2. So 1 has matched. Original list, it has matched. Remaining part is T1. Now I have to check for T1. So the next goal is palindrome T1. Next is palindrome T1. Palindrome T1. Version 3, anyone has doubt? So rule number 1, empty list is a palindrome. Null string is a palindrome. String having single element is a palindrome. And rule number 3, I split my original list into head and tail. So once again the example 1 2 2 1. So I write 1 2 2 1 and 1 is my head in this example. The value of the tail is 2 2 1. I am reversing the tail, so that 2 2 1 becomes 1 double 2. So in that reverse 1 double 2, this H, already H equal to 1, this must be 1. So T1 will be double 2. So 1 has matched in 1 2 2 1, 1 from the beginning and 1 from the end. They have matched. Remains this 2 2, and 2 2 is stored in the variable T1. So I have to check that T1 has to be a palindrome. That completes the definition. That's all. Any doubt in palindrome version 3? Palindrome version 3, anyone has any doubt? I'm waiting for the response. Palindrome version 3, is that clear to all? Janik, that is clear. More feedback? Kata, clear, fine. Any other? Rushabh, okay. Nemish, okay, fine. Anyone has doubt in this version? In fact, I have written 2 more versions. for palindrome, version 4, version 5. I'll be putting that in the group. You can check it out. We don't discuss version 4 and 5. Same, only little difference in the logic. Those are versions 4 and 5. I'll be putting that soon in the group. You can just check it out. Okay, fine. Thank you.
Thank you, sir. Good morning, students. This is for lecture, subject BDA. Quickly asking about the yesterday's status. If you remember, those who attended, I did request you to work on one of the practice data set, and hopefully many of you would have got chance to look at the problem statement. Anybody solved it in 5 minutes? Say yes in chat windows. Anybody solved it in 5 minutes? Anybody solved in 10 minutes? 15 minutes? 30 minutes? Fine, I think I should ask, anybody has solved it? Okay, maybe it was very short time and I'm not certain if you like to work after hours or not. Uh, anyways, that challenge I'll keep it open. Okay, you work whenever you get find chance. Then we'll discuss. There is not much to discuss there. It's a plain simple first semester program actually. But then being in 7th sem, how proficient you are, that's what I wanted to learn. Okay, and you might not write your own solution if you have a simple task at hand. Will you really write your own solution or will you use the existing utilities? That's what I wanted to learn from you. Uh, there's nothing like right or wrong answer. Okay, based on whichever tools you are proficient with, you may use and solve the problem. I remember one of my friend working at Bloomberg telling me, Jigar, if my manager asks me to do like this, my job is to get it done first. Of course, I would have my insight, my experience to help me, but then my job is to get it done. And of course, the efficient way possible, but not always. Okay, so make sure you know what you're working on and you know your timeline. And of course, based on that, you should act to choose the tools or technologies, to solve a problem. Fine, we'll move on. So, anybody has not found time to solve it, or okay, it was shared in lecture 8 on BDA conduit folder. In lecture 8, there is a zip file, I believe, which says practice data set 1. So maybe over weekend or whenever you find time, please work on it. But make sure you time it. Okay, the important factor here is the time and the technology what you may choose to get it done. Once you understand the problem statement. Okay, so again, by tomorrow's lab, see if you can install MongoDB. Fine. I may ask to fill Google form to know who stands where, and there will be multiple tracks tomorrow. Right. I'll be helping other students for previous map reviews, and remaining students may continue with MongoDB project. Right. Okay. So let's quickly go through the map reviews framework supported by MongoDB itself. Okay, so here is this official page, like docs.mongodb.com, manual reference command map reviews, right? And then, of course, there will be syntax, right? So if you remember, I told you in the past that MongoDB let you write JavaScript-like functions also. So functions are one of the kind of component. For example, with respect to Oracle database, if I have to say, we will say table, then username, uh, like view, index, etc. are components, right? That way, functions can also be termed to be one of the component in MongoDB. Okay, so of course, when we say map reduce, we'll have to write some logic like map function as well as reduce function, right? And the framework has to be there in place. So MongoDB has implemented framework, whatever the map reduce prototype is, and it let you, write function logic of your own problem statement. How will you do that? There is a complete, example over here to get you started. Uh, Fine. So we'll see the syntax. Actually, this is the map reduce, right? So map and reduce. So here you have to write the function name, whichever you might have created already for mapper. Here you have to write whichever function name you might have created for reducer. Fine. Then actually, you can also, because this is MongoDB, which is a distributed database, right? So data will be coming from some or other collection, right? And then before bringing all the data to the MapReduce framework, you can actually filter them out. It's very simple. You know how to filter with respect to database. There's nothing but a where clause, right? So here also there is a possibility of a where clause. So you, before data is being fed to MapReduce framework of MongoDB, you can write some kind of filter, uh, very much like a where clause, which will actually only the output of that query will be fed as input to this MapReduce program. And then, of course, the output of MapReduce program you would want to write somewhere. And again, this is not a file storage like HDFS. This is database. So the output will be stored in form of collection only. And we know collection, when we say collection, it is nothing but a type of table, right? So the flow control is the framework will call your map function, and then framework will call your reduce function. And before that, the data will be provided by the query, what you provide. Maybe that query will have filter applied, right, like a where clause. And of course, the output of reduce, you would want to store somewhere. So you have to provide the resulting collection name. Now, there are a few more things here, like verbose, etc. So those all things you can explore. Fine. So if you may want to read each and every, what is the purpose of that, right? Map reduce, the first field, it is the name of collection on which you want to perform map reduce. So here you have to provide the name of collection. There is nothing but the table, okay, on which you want to perform map reduce.